Hello everyone, we are back. We are looking at chapter 3, section 5. The word reciprocal is the key. It means a flip basically. 2/5 flips over to 5/2. 6 or 6/1 can flip over to 1/6. In algebra we can use variables as you could see there and flip them. And we're going to use this idea to make fractions a lot easier to work with when we're solving equations. Here's an example. As you could see, the reciprocal of 3/5 is 5/3 to both sides. And when you multiply them, you can see quickly that the fractions cancel out, and you get -45/3, which is -15. Let's try one. The flip on this is 3/-2 times -2/3 n, and you do it on this side as well, like so, 12/1, and that part cancels out, and all we do is arithmetic over here. 3 times 12 is 36, 2 times 1 is a -2, and we get -18. Same thing happens here. We put a 2/1 there, that'd be easier. And then we can do 1/5 because that is 1/5. C minus 3, 2/1. The flip or reciprocal on 1/5 is 5/1, 5/1. And you get C minus 3 equals to 10. We do the opposites like we have been doing. As you could see now, we get an answer of 13. Same thing happens here. You say, well, we have two fractions. What do? Well, we put denominators together. 2 times 5 times 1. A denominator here would be 10, because 2 times 5 times 1 is 10. And what does that mean? We're going to multiply everything by 10. And so we multiply by 10 here, multiply by 10 there, and multiply by 10 there. 10 times 1 is 10/2k. 10 times 3 is 30/5. And then 10 times -4 is -40/1. And we can quickly see 5k plus 6 equals -40. And the fractions are gone. We keep going, subtract 6. We got 5k equals -46. Divide by 5, and it's okay. You get a fraction. Don't panic. Fractions happen. And we can leave it like that. Now the decimal to this, if you want, would be a -9.2, because 5 into 46 is 9, and 1/5 is 0.2. Same thing happens here. 1 times 5 times 1, we can see denominator is equal to 5. So we're going to say 5. You multiply by 5 on this one, by 5 on that one, and by 5 on that one. 5 times 4 is 20y here. 4 times 5 is 20/5. And 8 times 5 is 40. This reduces down to a 4. And then, as you could see, no more fractions. We just keep going. Plus 4, 20y equals 44. Divide by 20, and you get 44/20. We can reduce it by 4. 4 times 11, 4 times 5. And we get finally 11/5. Now we can do the decimal. 5 into that is 2, 2.2, because 1/5 is 0.2. Now this next one is an interesting one because it's sort of in between algebra and arithmetic. Lisa took $60 to the mall. She spent 3/5 on phone accessories. Let's see how much that is. 3/5 of $60 would be 180 divided by 5. 5 into 180 is going to be as you could see, 36. So she has spent $36 on phone accessories. How much does she have left? Well, 60 minus 36 is borrow, and you get 24. Now here's where the arithmetic and algebra tend to be overlapping here. She says 1/2 of the remaining amount, which is 24, 1/2 of the 24 is for bus fare. And 1/2 of 24 is going to be $12. Now, there is nothing else. We don't have to worry about an equation or anything else. How much did Lisa have for bus fare? She had $12. Next one. This is a reading problem. 2/3 of a number. 2/3 of a number. And 1/2 of the same number. 1/2 of the same number is equals 7. We're looking for the number n. Again, we do like we did before. We look at the denominators here. Sorry about that. 3 times 2 times 1 is going to be 6. So the denominator we need is a 6. And so we multiply everything by 6. Like that. 6 times 2 is 12 over 3n, plus 6 times 1 is 6 over 2n, equals 6 times 7 is 42. 4n plus 3n equals 42. 7n equals 42. Divide by 7, and you get an answer of 6. So this involved reading the problem and translating, and then using our multipliers to get a denominator and clear out the fractions.